Welcome back. Today we will be talking about the asymptote of the rational functions, how to find the domain of the rational function, vertical asymptote, horizontal asymptote, and slant asymptote as well. So when we are talking about the uh, rational functions are nothing but the quotient of polynomial functions. And in the form of the function, I can write it down as f of x is equal to n of x divided by d of x, which is nothing but the polynomial of the numerator divided by the polynomial of the denominator, provided we cannot have denominator equal to 0. Because when we have denominator equal to 0, technically that is nothing but a vertical asymptote. As you can see on the graph on the right hand side, this is a parent function of a rational function, 1 over x, and how it is behaving in the first quadrant and the third quadrant. Now, why it is behaving on the first and the third quadrant in these rational function, when we are talking about the domain, there are two things we need to keep in mind. All real numbers except the x values that can make the denominator 0. As I said earlier, when the denominator is 0, that is a vertical asymptote. Why vertical asymptote? Where the function will be undefined, because when 0 is under, that is undefined. The another thing that we need to keep in mind with respect to the domain, that will be the negative even roots. So when we are talking about the negative even roots, we cannot take a radical of a negative number. Technically we can say we have the imaginary number, but those roots will not be the real roots. In this case, we are talking about only the real roots. Now, keeping this thing in mind, um, let's take it to the further. If I have to look for the graph and how the domain of this parent graph works, as I move towards infinity, towards the positive, right? But from the right hand side, if I'm moving towards the 0, towards the origin, that is called as x approaches to 0 from the positive side, the y function, it is increasing without bound. So y will be increasing, that means the height will be increasing as we will be approaching x from the positive side. As we approach 0 on the x-axis from the negative side, f of x tends to decline without bound. So 0 from the positive, increase without bound. 0 from the negative, it will decrease without bound. When they say without bound, that means without any restriction. It will keep on increasing or it will keep on decreasing. There are certain steps that can help us to find the domain. So first step would be set the denominator equal to 0. So when we set the denominator equal to 0, you will get certain x value. That x value is where there will be an asymptote, and at that point, the function will not be defined. Second is solve for x, because if you are putting the denominator equal to 0, you need to solve for x. And the third, domain will be all real numbers except the value of x that you got in step number 2, because that value of x, that is my restriction. So keeping these 3 steps in mind, domain will be always accurate. So for the rational function, eventually we will do the graphing of the rational function. For graphing of the rational function, again, you need to find the domain. Okay, now let's move forward. Once we know how to find the domain, we know how the function will behave on the x-axis. And based on the parent function, I can evaluate where it will be increasing without bound or decreasing without bound. As you can see in this example on the right, we have vertical asymptote at x is equal to 0 and the horizontal asymptote at y is equal to 0. But what is the meaning of asymptote? So asymptote is nothing but a line that a curve approaches as it moves towards infinity. It can be positive infinity or a negative infinity. A few things about the asymptote. The biggest question is, can I cross the asymptote? The answer is no. You can, technically, you can cross the horizontal asymptote, but we cannot cross the vertical asymptote. So curve never touches the asymptote, especially for the vertical asymptote. There are cases that are where there will be questions where you can cross the horizontal asymptote, but those are not the scope of this course right now. Another thing, distance between the curve and the asymptote tends to be zero as it approaches positive or negative infinity. That means what they are trying to say, as we can be very, very, very close to the asymptote, but we will never, never touch the asymptote. That is why the distance between the curve and the asymptote, it tends to be zero as we are approaching on the x-axis, either to the positive infinity or negative infinity. This theory will get a little bit more clear when we solve few problems, few questions in hand. And when we sketch the asymptote, we sketch the asymptote with the dotted line, right? Just like in this example on the right-hand side, we have a dotted line for the vertical asymptote and the dotted line for the slant asymptote as well. Now let's understand vertical asymptote and horizontal asymptote a little bit more clearly. So when we are talking about the vertical asymptote, we are talking about x is equal to some value, because vertical asymptote implies that x will be having a some value and I will be sketching a vertical line. That is the meaning of vertical asymptote. On x value, we will have a vertical line. So f of x approaches to infinity, or f of x will approach to negative infinity. It will depend whether we are approaching the asymptote from the right hand side or we are approaching from the left hand side. So as x approaches to a from the right or from the left, that will define the height of the function, which is nothing but f of x. Clear? Now, the another thing, because the common mistake is we are talking about the vertical, so students, they try to sketch a line on y. No, it is a vertical line, but the x value. On the other hand, when we are talking about the horizontal asymptote, it is just the opposite, right? So we are looking for a y value. So y is equal to b will be the horizontal asymptote. And as we approach infinity on the x-axis, so as x approaches to infinity or as x approaches to negative infinity, we are looking for a y value. And on a y value, we are creating a dotted horizontal line, because that is the meaning of horizontal asymptote. There are certain rules how to calculate the horizontal asymptote that we will discuss very shortly. And those three rules will always help you to find out the horizontal asymptote with ease. The third type of asymptote when we are talking about, that is called the slant asymptote. So slant asymptote, technically we use synthetic division to calculate the slant asymptote. So f of x is equal to x squared minus x over x plus 1. So if you can see, the difference between the highest power of the numerator and the highest power of the denominator is exactly 1. So when the difference between the highest power of the numerator and the denominator is exactly 1, we can use synthetic division to find out the slant asymptote. That is the whole entire thing. So you can see the graph of f of x is equal to x squared minus x divided by x plus 1. It is graphed already on the right hand side of your screen, right? So that is how you will calculate the slant asymptote. You need to have a good understanding of synthetic division. If you don't know synthetic division, then you can also go for a long division. So choice is yours. In many textbooks, they just focus on synthetic division using linear function as a divisor. In the denominator, we have x plus 1 as the divisor, right? But you can use synthetic division even uh, if you have to divide by a quadratic. The process will be same, but it will have another layer in the problem. So in this particular case, denominator is a linear function because we have x plus 1 and it is in the format of y is equal to mx plus b. As you can see in the graph, we have a vertical, horizontal asymptote. We are not talking about here, but you can say slant asymptote is listed as a dotted line, which is x minus 2. Now, how to identify the horizontal asymptote? There are three cases for horizontal asymptote. So we will call it, for the simplicity's sake, easy to understand, we will say bot, bob, and sauce. Now, what they are. First one, bot. Bot implies big on top. When I say big on top, it implies the highest power is in the numerator than the denominator. So the numerator's highest power is greater than the denominator's highest power. So highest degree of numerator is greater than highest degree of denominator. In these cases, we get horizontal asymptote as a slant asymptote. You have seen in this case, right? On the left hand side, x squared minus x divided by x plus 1. So highest power is in the numerator and the lowest power is in the denominator. So we are looking for the slant asymptote. So bot will give you a slant asymptote. Slant asymptote is also called oblique asymptote as well. Now the another is bob. That means big on bottom. And the highest power in the denominator is bigger than the highest power in the numerator. In that case, we can safely say the horizontal asymptote will happen at y is equal to 0. So the horizontal asymptote will be at y is equal to 0. Now the last one, we have sauce. But before that, let's take one example. So let's f of x is equal to 3x plus 1 divided by x squared plus 5x minus 6. So highest power in the numerator is 1, but the highest power in the denominator is 2. So which has the highest power? The denominator, right? So the asymptote will be at y is equal to 0. Sauce implies when the highest power in the numerator is equal to the highest power of the denominator. When things are easy. Then the horizontal asymptote will happen at leading coefficient of numerator divided by leading coefficient of denominator. So if you understand bob, and sauce, just by looking at the function, you can evaluate, you can know where the horizontal asymptote should be. So leading coefficient of numerator divided by leading coefficient of denominator. Let's take another example. So f of x is equal to 3x squared plus 2x divided by x squared minus 5. So the highest power in the numerator is 2. Highest power in the denominator is 2. So the leading coefficient is 3 in the numerator and the leading coefficient is 1 in the denominator. So the horizontal asymptote will be 3. That will be my horizontal asymptote. So remember, bot, bob, and sauce for horizontal asymptote. For slant asymptote, you are dividing them. For the vertical asymptote, you are putting the denominator equal to 0. So let's, in this example, let's take 2x squared over x squared minus 1. Just by looking at it, what we are using? We are using sauce, because the highest power in the numerator, highest power in the denominator, they are same. So the horizontal asymptote will be 2 over 1, which is nothing but only 2. And you can see in the graph, we have a horizontal line. Now the vertical asymptote, if you put denominator equal to 0, you are getting x squared minus 1 is equal to 0. And that will give you x is equal to positive and negative 1. That is why you can see two vertical asymptotes at x is equal to negative 1 and x is equal to 1. Right? And once I know where the asymptotes are, I need to graph. How? I need to graph, you got the asymptote points. So check the points on the right and on the left side of these asymptote. And then make x and y table and then graph the function. If you are talking about the slant asymptote, there is no slant asymptote because the highest powers are same. When the highest power, they have the difference of 1, then only we check the slant asymptote. Otherwise, we don't check the slant asymptote. All right? So I have graphed the function for you, but try to graph it on your own without using the graphing calculator. You have all the asymptotes and see whether you are able to graph the function properly or not. Now, a few steps we need to keep in mind for vertical asymptote, because we have just talked about verbally. Let's write it down. So the first thing is you need to factor numerator and denominator if possible, because I cannot directly put the denominator equal to 0 to get the vertical asymptote. First, it needs to be in the factored form, and if there are any cancellation or if there are any restrictions in the domain, we need to write it down. So write any restrictions. Restrictions implies if there is any hole. If you factor the numerator and denominator, the factored part, that is a hole. That is a hole in the graph, right? So you need to write it down if there is any hole in the graph. Then after factoring, it is a good idea to cancel any factor because that will help us to find the hole again, and it will help us to simplify the denominator. Once we have a simplified denominator, I can put the denominator equal to 0. Then write all the values that will make denominator equal to 0. Right? Now, another step you need to remember, because students will make mistake in finding the hole. That is why I want you to write it down for your understanding, that remember the common factors from the numerator and denominator will be a removable discontinuity, which is nothing but a hole in the graph. So it is nothing but removable discontinuity. Right. So this is the basic idea of how we understand the rational function, the various asymptotes. Now let's understand it again one more time. Let's summarize everything with this example. So f of x is equal to x squared minus 1, x squared minus 2x minus 3. Now take a moment and think how we can factor the function, because we have a minus b in the top and a plus b, a minus b times a plus b. Can I factor the quadratic? X squared minus 2x minus 3 will give you x plus 1 times x minus 3. Now, because we are able to factor it out, you can see I can cancel out a factor x plus 1 and x plus 1 from the numerator and denominator. And that is where we will define the whole. So x is equal to negative 1 will be a whole, and that is nothing but a removable discontinuity. Now, what is left? X minus 3 is left in the denominator. That is where we will have a vertical asymptote. The highest power in the numerator and denominator, they are same. So can I evaluate horizontal asymptote? Horizontal asymptote will be what? It will be leading coefficient of the numerator and the leading coefficient of the denominator. So we are using SOS, same on same. So y is equal to 1 over 1, which is nothing but 1. Is there any slant asymptote? No, there is no slant asymptote because the highest powers are same. Let's see if we have a graph for this function or not. I believe not. So let's find this one. So the vertical asymptote will be what? Highest powers are same. So it will be 1. The horizontal asymptote will be 1. The vertical asymptote will be negative 1 because we are putting the denominator equal to 0. And horizontal asymptote will be only 2. 2 divided by 1, which is nothing but 2. And we are using SOS. Right? So just practice these questions and practice these steps. Remember slant asymptote. We will not have slant asymptote in each and every problem. We can use BOT, BOB, and SOS for horizontal. And I will see you in the next video.